Hello guys, welcome back. In this video, we are going to discuss a new topic, recurrence relation. Wait. Recurrence. It's like relation. So recurrence relation have two types. One is determinant order and indeterminate order. Uh, Determinant order is of two types, LRR, non-linear, linear recurrence relation, and non-linear recurrence relation. Linear recurrence relation is also of two types. Linear recurrence relation, uh, C, C, C. Linear recurrence relation CC is also two types, right? LR CCH homogeneous and LRCCIS inhomogeneous or non-homogeneous. All right. These two types are important, and wait a minute, guys. I have to. All right, guys. Let's start. So, all right. So, one thing is order of recurrence relation is equal to highest index minus lowest index. So, for example, a of n is equal to a of n minus 1 plus a of n minus 2, right? Of indexes, right? So, what is next is order of recurrence relation. Order of recurrence relation equal to 2. Hello? Hello? Suara mau nyanyi bar? Nyanyi ya? Hello? Hello? Kata isa lagi. Hello? Order of recurrence relation is equal to 2. So it is a determinant order here, right? For example, 2 plus 6. The order is n minus n by 2 is equal to n by 2. So it is indeterminate order. Next is linear recurrence relation. In this, what we will do is power of a is what is linear recurrence relation? Now we will discuss here. So in this, power of a is 1, right? For example, if a minus 2 plus l square, this is linear recurrence relation because all power are 1 here, 1, right? For example, but let's say we have example a of n is equal to square root of a of a1 plus n. So here power is 1 by 2 here, alright? So this is non-linear recurrence. Right. Next is linear recurrence relation with constant coefficient. It is linear recurrence relation with constant coefficient. Right. Coefficient of A is constant. Right. So let's say we have A n equal to 5 of A n minus 1 plus 6. 5 is a constant which is a coefficient of A. But if it is A n is equal to n A of n minus 1 plus 6. So this is coefficient is not constant. So this is with variable coefficient. Right. So next is linear recurrence relation with constant coefficient and homogeneous. Right. So what is it about A of n? Let's say A of n is equal to 5 minus 3. Right. Then what? Then A of n minus 5 A n minus 1 minus 6 A n minus 3 is equal to 0. Minus 3 equal to 0. Then it is homogeneous. But what if it is like A of n equal to 5 A? It is not equal to 0, so it is inhomogeneous. Right? So let's say solving a recurrence relation by characteristic root method. How can we solve them? To solving recurrence relation by characteristic root method. What is this? For linear relation homogeneous, that it is fully solved. So how we do this now? Let's say we have a recurrence relation A of n is equal to 5a n minus 1 minus 6 a n minus 2, and a of 0 is equal to 1 and a of 1 is equal to 5. Alright, so what we will do here is, so what we find the order of this. Alright, so highest is n minus n minus 2 is 2, so it is of equation is of second order. Alright, and then what? So if note here is, if uh, if order of recurrence relation is n, then n termination conditions are required. So here two termination conditions are required as order of recurrence relation is 2. Right? So now what we will do, we have two termination conditions already like this. So we will make it a homogeneous this equation a minus 5a minus 1 minus 6 a of a minus 2 is equal to 0. So so one most note is here. Now next step, represent lowest index equal to 1, next by t, and next the t square, and so on. Note this is like t square minus 5t minus 6 is equal to 0. After solving this, t is equal to 3 over 2. So what we will do is here, for solving this, solution here is c1 alpha to power n plus c2 beta to power n plus c3 log to power n plus and so on. Now what a of n is c1 alpha and beta are the roots of the equation, and now a of 0 is equal to c1 uh, plus c2, a of 0 is equal to 1, and a of 1 is equal to 3c1 plus 2c2 equal to 5, which implies c1 is equal to 3 and c2 is equal to 2 minus 2, right? Minus 2, and now a of n is equal to 3 into 3 power n minus 2 into 2 power n is equal to 3 into n plus 1 minus 2 of n plus 1. This is a solution for the recurrence relation. Right. So here roots are not repeated. Right. Alpha equal to 3 and beta is equal to 2. So here roots are not repeating. Right. So what we will do is we will find the next question for next topic when roots are repeated. So in this, wait a minute guys, I have to do some work here. Wait a minute guys. Right. Alright, alright guys. So next topic is for us is when root repeat itself. When roots repeats themselves. So what will be the formula for that is a of n is equal to c1 alpha to power n plus c2 n alpha to power n. Alpha is repeating here plus c3 n minus 1. No, this is not like that. Not n minus 1. It is n square alpha to power n and so on like that. Then plus ci uh, beta to power n like that. Alright. So question here is like a of n is equal to 5 a of n minus 1 minus 6 a to power n minus 1 n minus 2. So a of 0 is equal to 1 and a of 1 is equal to 1 is equal to 5. Two termination conditions. Alright. So how can we solve this? Let's say how we are solving this by, let's say uh, a of a minus 5a minus 1 plus 6a n minus 2 is equal to 0 like that. Then what we will do here is so now what we will do is our light. So let's say how we are going to solve it, like n square minus 5t plus 6 equal to 0. Let's 2 and 3. It's same as I think previous one. T square minus 3t minus 2t plus 6 0. T is equal to 3 over 2. Alright. These are this values now. What we are going to do is here is Right. Now this what was this, what is the not repeating here also. This is not the case. What we are doing a short trick for this. We are focusing options are we are options 3 to power n plus 2 minus 2 to power n plus 2. B is 3 to power n plus 1 minus 2 to power n plus 1. E 5 to power n. D is 3 to power n minus 2. So what we are going to do is A of 0. N is equal to 0 is equal to should be 1. Right. Is A 0 1 uh, 3 0 put 0 here. 2 9 minus 4 is 5. No, 3 minus 2 is equal to 1. This is correct answer. B is the correct. And 5 to power n is also 1. So we will check for A1 here. A1 is equal to 5 also. This is also 5. So we will check for A2 here. A2 is what? 5 of A n minus 1 n minus 2. So 5 of A n minus 1 is 2 minus 1 A1 and minus 6 A minus 2 minus 2 minus 2 0. So 1 6 5 25 plus 6 minus 6 is equal to 19. So we go to this 25 19. 25 is equal to 19. So B is the answer. Right? This is how we do it. Right. So next question we are discussing here is, let's say, linear recurrence relation, constant coefficient, M homogeneous. We are going to discuss. RHS is not equal to 0 in this. RHS could be polynomial, could be power uh, exponential, and could be combination of polynomial and exponential. All right. These are could be some. Let's say A of n is equal to 5 of a n minus 1 minus 6 a of n minus 2 plus 5. A0 is equal to 1, A1 is equal to 5. Like this. So A of n is equal to A of n h plus A of n p. This is homogeneous part. Homo part, this is particular part. Right? And this what we will do. A of n h equal to 5 a of n minus 1 minus 6 of a n minus 2. Right? And 5 becomes here 0. So then A of n to 5 a n minus 1 minus 6 of a n minus 2. So this will become same as t is comma 3 comma 2. So A of n is equal to c1 into 3n plus c2 into 2 to the power n. This is equation 1. Uh, Next equation is RHS is constant here. A of n p equal to d. Then A of n is equal to d. D is equal to 5d minus 6d plus 5. D is equal to 5 by 2, like this. Is it correct? Then A of n is equal to A of n h plus A of n p is equal to c1 to the power n plus c2 to the power n plus 5 by 2. Instead of a n, we put d here. Then a n minus 1, a n, let's see, first a n barabar d implies a n minus 1 is equal to d also, right? Right. So after solving the equation, c1 is equal to 11 by 2, comma c2 is equal to minus 7, and which implies a of n is equal to 11 by 2 to the power n minus 7 to the power n plus 5 by 2. This is the answer. So some notes here. Notes here are repeated notes, notes for same as homogeneous one. And so if one root is 1, right, is equal to 1, then a and p is equal to d into n. So what is this? Why is this? Let's say, for example, a of n to power n, not n, this is h plus a of n p, right? It is equal to c1 into 1 to the power n plus c2 into 3 to the power n plus d to the power 1. This is c1 plus c2 power 3n plus nd. It is because to avoid collision multiply by n and d. Alright guys, thank you so much for watching the video. We will meet you in the next one.